Hey everyone, I hope you guys are doing good. Today I'm going to be discussing problem J1 of the 2024 Waterloo contest, conveyor belt sushi. So the problem description includes, there is a new conveyor belt sushi restaurant in town. Plates of sushi travel around in the restaurant on a raised conveyor belt and the customers choose what they eat by removing plates. So here's where the important part is. Each red plate of sushi costs $3, each green plate of sushi costs $4, and each blue plate of sushi costs $5. So they have a tiering system in which, based on the color of plate that the sushi is, there's different pricing, right? Red is 3, green is 4, and then blue is going to be 5. Now your job as the developer is to create a program or computer software that will determine the cost of a meal given the number of plates of each color. So you're gonna basically, this program will give the input of each of these plates, right? The amount of red plates, green plates, and blue plates, and then you are supposed to spit out how much it would cost. So that's actually shown in the input specification, in which is telling me that the first line of input contains a non-negative integer of r representing the number of red plates chosen. As you can see, the first input will be how many red plates there are. Second line is the same logic, but it's represented with the variable g, and it's the number of green plates chosen. The third line is the variable of b, and that represents the number of blue plates chosen. Then in our output specification, we only need to output one thing, and that is going to be the cost of meals in dollar. And the way that we can figure this out is based off of the pricing of each of these plates, because we're given that amount in dollars through here. Alright, so as you can see here in our sample input, if we take a critical dive into this, I'll use my screen brush to kind of guide you guys. This line here is going to be the amount of red plates. This line here is going to be the amount of green plates. And this line here is going to be the amount of blue plates. And that's because over here you can see the first line of input is R, or the amount of red plates chosen. Second line is G, which represents the number of green plates chosen, and then the final line is the B, which represents the amount of blue plates chosen, right? So let's actually code this out. All right, before we start that, it's important to start off with your title block. Now this is just something that is something that my computer science class makes me do, so I just kind of, when I'm working on these type of problems, I kind of do it so that I have the practice of doing it, right? So this is going to be J1 2024 solution. Instructor name. I'm going to keep some of this stuff private. I don't want to share it, right? But yeah. Okay, there we go. So that's our title block here. Now, obviously, in real programs, when you're working at jobs, you don't really need to add these comments. But, in a educational setting, you probably will have to. It just helps probably them, like the instructors, figure out, who you are, because they have multiple Python files they have to, kind of work on. Anyways, I'm just gonna save this as J1 2024, and there we go. Let's get started. So we're gonna start off with our input, which are simply just variables. We can just use the names that Waterloo has given us of R, G, and B, right? So we'll start off with R, and they're inputs, right? And they're integers, specifically non-negative integers, but we don't have to worry about that, because that's just that makes our life easier, actually, because we don't have to deal with negatives. But the important part is that it's an integer, so we want to keep this input as an integer input, and we can do that by wrapping the input prompt with an integer value like this. So we just take this input, which by default is a string, and just convert it into an integer. And then we're going to do the same exact process again and again. So green input, and then B integer, So there we go. We now have the different inputs that are required based on the input specification. Now what we will do is we will work on the logic of finding out the value of C, which we'll also write as 0 in a variable, right? And we just need to now figure out how we can get the value of C, right? Like how much it's worth. And we can do that with actually multiplication, because we're saying that each red sushi plate costs $3, then each green sushi plate costs $4, and each blue plate of sushi costs $5, right? So all we really need to do here is we need to figure out how much of each would cost, right? So all we'll do is we'll start off with the red, and we'll say C equals, or plus equals, I should say. And basically what this means is we're incrementing the amount of numbers in C by a specific value, which is going to be R times 3, because remember the red plates cost $3. Now we'll apply the same, or you know what we'll do actually, instead of this, we'll actually just say equals to this. And then we're gonna add the green plates, which is multiplied by 4, because remember green plates cost $4. So each of the green plates over here should be added. You should add 4 for each green plate you have. Use multiplication for that, right? Same thing with blue plates, 5. So it's very basic addition, you know, elementary addition. But there you go. Now all we need to do is just simply print C. We can go ahead and save that, run the module, and in here we'll add this of 0 to 4, and as you can see we get a 28 output for our specific value. So you can see that it works perfectly fine. So now I can go ahead and take this and put this on my GitHub, and that's exactly what I'm going to do. But before I do that, I'm actually going to find J1 2024 CCC Waterloo. I'm going to try to find it on the over here. Let me just, this is just a platform where you can submit your problems, and they'll actually give you if you passed or failed. As you can see, I passed all my cases, so yeah, this is perfect, because on the actual test, or on the thing, it only gives you like 2, maybe at maximum 3 use cases. But over here you can see that there's multiple use cases, so you just want to make sure that it passes all of them so you can get full marks, right? The thing is though, on the competition, you probably won't get all of them correct, because it's meant to be tough. Maybe J1 and J2, but when you enter J3 it gets a little bit more tough, right? So you might not get all of them, but you will still definitely get partial marks, right? But anyways, enough of me rambling on. Let me just add this to my GitHub. And to do that, I actually need to go to the over here, because I need to create a new folder of 2024, and in here it's gonna be sushi conveyor belt.py, and then let's add this. I'm using Vim, by the way, so that's why, you know, I have this weird cursor type thing going on. And then git add, git commit am, added 2024 folder plus sushi conveyor belt issue, git push u origin main, git pull origin. And so now if I just look at my GitHub profile, go to my repositories, go here, you'll see that now I have a 2024 folder, and within here I have the problem right here. So you guys can also try it out for your own you know, for your own reference or for your own studying. One thing that I'll actually do, so going back to my idle, is I'll actually add some comments, because comments are very important. It lets your teacher know, especially like in the competition itself. It's fine if you don't comment, right? Because it's purely based off the output. But when you're submitting it for tests, especially like a computer science class, this is my intro to computer science class. It's important to comment your code so your teacher knows that you actually understand the logic, right? My teacher even said that even if your code doesn't run, like you literally get an error, as long as you commented everything and he understands the code, you'll get an 80. Just imagine that you'll get an A minus, if even if your code doesn't run, as long as you commented. That's the importance of commenting. So anyways, let's comment this, and we're gonna start off over here. The inputs for the plates, the colored plates, the inputs for the amount of different colored plates, the output, and then here we're just going to say the math involved in figuring out the cost based on the amount of plates and their cost per unit. Okay, let's save that, and when we run it we shouldn't see any problems, but I just want to make sure again. And as you can see, there's no problems because comments don't really affect anything. But here I can just edit this file and just add this new commented file. Let's update this, and there we go. Now this is officially commented and a much more suitable for grading in a class or an academic situation. Alright, that's it from me, and I hope you guys enjoyed this video.